Hi friends, in this session we will see mean value theorem. So one or two questions may be asked in TRB exam. So let us start this. So I'm not going to explain the derivation. I just give the concept and we can solve the problem, which is enough to solve any problems in the competitive exam. Okay, let us see that we have some importance theorem in this. First one is intermediate value theorem, right? So what it is telling is, we know if you have a function y is equal to f of x, which is continuous in the closed interval, right? So in the closed interval ab, it must be continuous, our function f of x. And k is any number between f of a and f of b. So we find any number f of a and f of b. This is a number, and k lies between f of a and f of b means, right, there must be at least one number lies between a and b, which is c, right, such that f of c is equal to k, where k is a number lies between f of a and f of b. If there is a number which lies between f of a and f of b, for example like this, let us assume this is a curve f of x, right? So let me assume this point is point B and this point is point A. Fine. So this location is f of B and this location is f of A, right? So if k lies between f of B and f of A, right? K is a number between f of B and f of A means there must be corresponding number which is nothing but c, which lies between a and b. Fine. So that's what they are telling. This is what intermediate. So we know this value lies between the AB in x-axis. So and f of b and f of a is in y-axis. If there is a value such as called k lies between f of a and f of b means, sorry, here f of a and f of b means there must be some value between, correspondingly there must be some value between a and b. That is what the intermediate value theorem, right? So next just we have to understand that, but these two theorems, Lagrange's theorem and Rolle's theorem, are playing crucial role in the problem solving. So as usual they are telling, if see every condition you must study very carefully, because based on the condition itself they will ask question. So Rolle's theorem, let f of x be continuous. So first thing, the given function must be continuous where it is in the closed interval and differentiable in the open interval. So differentiable in the open interval. So this is closed, this is open interval, right? So what are the condition? The function f of x must be continuous and it must be differentiable. And third one is f of a is equal to f of b. If all the conditions are satisfied, three conditions, then there is at least one point C which lies between a and b, right, and open interval which lies between a and b, such that f of c is equal to 0, right? So whenever we want to apply Rolle's theorem, first we have to check the given function is continuous, the given function is differentiable in the open interval, the given function is continuous in the closed interval, and also we have to check f of a is equal to f of b. If all the three conditions are satisfied, Rolle's theorem states that there must be one value c which lies between a and b, such that f dash of c, not f of c, f dash of c must be equal to 0, right? So that is the important theorem, right? So this is what Rolle's theorem. Okay, next another important theorem is Lagrange's mean value theorem, right? So here also you see, yeah, the function f of x must be continuous as usual. So f of x should be continuous in closed interval a to b and differentiable in open interval a to b, right? Where f of a and f of b are not necessarily equal. Here we don't need to check f of a is equal to f of b. Whereas in Rolle's theorem, f of a must be equal to f of b. Then there exists at least one point C A B such that here f dash of C is equal to f of b minus f of a divided by b minus a. That is the condition. There we have seen f dash of C is equal to 0, right? So here, right, f dash of C is not equal to 0 because f of a is equal. See, when f of a is equal to f of b means what will happen? This will be equal to Rolle's theorem. Clear or not? In Rolle's theorem, the third condition is f of a equal to f of b. Whereas here, it is not necessary for Lagrange's theorem to have f of b is equal to f of a. If in Rolle's theorem, there must be f of b must be equal to f of a, but in Lagrange's theorem, that condition is not necessary condition, right? Okay, so here f dash of C is equal to f of b minus f of a divided by b minus a, right? But the first two conditions are mandatory. The given function must be continuous in the closed interval and it must be differentiable in the open interval. Okay, let us see the problem. The interval in which Lagrange's theorem is applicable for f of x is equal to 1 by x, right? So we know f of x is equal to 1 by x. This is continuous. I have to check the condition, right? So we know f of x is equal to 1 by x is a condition. So it is a continuous function in any interval. But when I take f of x, is it differentiable? No, it is not differentiable. It is not differentiable at x is equal to 0. Yes or no? So it is not differentiable at x is equal to 0, because if you take f dash of x, that is equal to minus 1 by x squared. When x is equal to 0, the function is not differentiable, right? So the function blows away, that is, it becomes infinity. So the function is not differentiable at x is equal to 0. So that x is equal to 0 must not be an interval, right? So here you see minus 4 to 0 plus 4, it has x is equal to 0. Every element is bothering about x belongs to minus 4 to plus 4. So here x0 is existing. So at that point, the function is not differentiable. So it is not correct answer. Minus 2 to plus 2, here also x0 is there. So wrong answer. 1, 2, 3, there is no x is equal to 0. This is right answer. Minus 1 to plus 1, here also 0 comes in between them. So at this point, the function is not differentiable, right? So C is the right answer. Next one, suppose f of x is differentiable. Yes, okay, they gave for all value of x with f of x is equal to 29 and f of 2 is 17. What is the maximum value, right? So you see f of x, f of x is equal to 29 they are given. It is not f of x, it is f dash of x, right? But f of 2 they are given. What is f of 7 they are asking. So I don't know whether f of 2 and 7 are not equal or not. In Rolle's theorem this must be equal, but I don't know about it, so I apply Lagrange's theorem. So what Lagrange's theorem states, f dash of C is equal to f of b minus f of a divided by b minus a, right? So this is f dash of, so I can consider this is f dash of C, so that is equal to 29, right? That is equal to f of b, you see lowest limit is a, upper limit is c. So f of a, f of b. So f of a, I don't know, f of b is 7 minus f of 2. So b is 7, a is 2. So f of 7 is, I don't know, that I have to find. F of 7 minus f of 17 divided by 5. Okay, so this indicates f of 7 minus 17 is equal to 145. This 5 I bring this side. So f of 7 is equal to 162. So the answer is 162. So what is the value? The maximum value is 162. Minimum value is 17, right? Okay. Next question. For which of the following function Rolle's theorem is not applicable? So whenever you want to apply Rolle's theorem, three conditions must be satisfied. f of x must be continuous in the interval a to b, differentiable in the open interval a to b, and f of a is equal to f of b. All the three conditions are satisfied means then f dash of c is equal to 0. That's what Rolle's theorem states. So here you see first one, mod. Mod is whatever be the mod is continuous function but not differentiable, that we know. So this function is continuous, right? Whenever we have a mod x function, for example, mod x, right? Mod x will be like this, right? So mod x is continuous, but at one point surely it will not be differentiable. Any modulus is not differentiable. So second condition fails. First condition okay, continuous, but second condition fails. So here we cannot apply. So this may be one answer. Next, tan x where x varies from 0 to pi. So we know tan curve will be like this, right? So it will be going like this. After that, it will be coming again. It goes up, right? So what will happen? 0 to pi. This is pi by 2 pi. Right, so at pi by 2, what will happen? Tan pi by 2 is infinity. The function is not continuous. That's why the curve will be like this. So when you substitute pi by 2, the function is not continuous. So it is not differentiable. It is not continuous. So I cannot apply Rolle's theorem. So second one also I cannot apply. Okay, third one, this is continuous, it's a polynomial, so surely it is continuous, right? Can I differentiate? Yes, if I differentiate 1 minus 2, 1 by x, so it is differentiable also. But what is f of a, f of a, f of 2, that is f of 2 is 2 minus 2 log 2. F of 7 is 7 minus 2 log 7. That means f of a is not equal to f of b. F of 2 is not equal to, that is f of 2 is not equal to f of 7. Third condition fails. So here also the Rolle's condition is not applicable. So what is the total answer? All of the above. So option D is the right answer, because for all the three you cannot apply Rolle's theorem. So option D is the right answer. Fourth one, suppose that for a function f of x, f dash of x is less than or equal to 1. F dash of x is less than or equal to 1. Interval is x varies from 1 to 4, closed interval. As usual, it includes 1 and 4, so closed interval. F of 4, show that what you have to do, f of 4 minus f of 1 must be less than or equal to 3. Okay, so as usual, we apply Lagrange's theorem. So f dash of c is equal to f of b minus f of a divided by b minus a, f dash of c, right? So a, b they have given. A is 1, b is 4. So f of 4 minus f of 1 divided by 4 minus 1. Right, f dash of c or something must be less than or equal to 1. So this must be less than or equal to 1. This is what our f dash of c or f dash of x, like that we consider. So this must be less than or equal to 1. So this indicates, from that what we are understanding, this implies f of 4 minus f of 1 divided by 3, which is less than 1. So if the answer should be less than 1 means, less than or equal to 1 means, what should be the value? The numerator should not go beyond 3, right? If the numerator goes beyond 3, it will become more than 1. So the condition fails. So f of 4 minus f of 1 must be less than or equal to 3. So that is the answer. If f of 4 minus f of 1 is 3, it is equal to 1. So this condition okay. Greater than 3, even it is 3.1, it will be greater than 1, the answer. So it is not satisfying this condition. So always f of 4 minus f of 1 must be less than or equal to 3. Right. Does there exist a differentiable function f of x such that f of 0 is minus 1, f of 2 4? So f of 0 is minus 1, f of 2 is 4. This implies a0, this is a, this is b. B is 2. This is f of b, f of minus a. So if there is a differentiation exists where f dash of x is less than or equal to 2, we are applying f dash of x, that is equal to f of b minus f of a divided by b minus a. So f of b is 2, 4 minus of minus 1, b is 2, a is 0. So that must be less than or equal to 2. Right, but what is that thing happening? 4 plus 1 by 5 by 2 is 2.5. 2.5 is not less than or equal to 2, so the differentiation not exist. So does it exist? Fine. Okay. Next question. If f of a, if a is greater than 0, b is greater than 0, that is both are positive. E minus a minus e power minus a minus e power minus b. What is the condition? So we have to use mean value theorem. We learned. So f dash of c, let us assume that is f of b minus f of a divided by b minus a. Right. So you see f of b, a is greater than 0, b is greater than 0. Right. And we have to find f dash. See, as per Lagrange's theorem, c must lie between a and b. Right. So we know e power will be like this. How e power will be e power minus a. So a is greater than 0. That means e power minus a, e power minus b, both will appear like this. This is what e power minus a curve with a greater than 0, or e power minus b curve with b greater than 0. When you substitute e power 0, it will become 1. When that is a0 means it will become 1. A is greater than 0 means they will be coming like this. A greater than 0 means it is positive part of the curve, and similarly b is also greater than 0, it will be positive part of the curve. Right? So negative part we don't mind because a is greater than 0, b is greater than 0. Then as per the Lagrange's theorem, c must lie between a and b, so c must also be greater than 0. Right? So this implies c also greater than 0. Clear? But it should lie between a and b. Clear? Now we take modulus because they ask mod e power minus a, mod e power minus b. Right? Okay, let us see. If you take mod f dash of c is equal to mod f of b. Instead of f of b, we substitute e power minus e power minus b minus e power minus a divided by b minus a. Okay, I take modulus later, right? So this is what my condition. Fine. Okay. Oh, sorry. Okay, you see from this diagram, this is what I have to do. So e power minus b, e power minus a. See, whenever you go, b is always this is what f of b, sorry, f of you see, this is what f of a, this is what f of b. So always b is f of b is less than f of a. F of b is less than f of a in e power minus a where a is greater than 0, and e power minus b where b is greater than 0. You see from this, f of b is always less than f of a. So it will be a negative. Clear? So denominator b minus a, that is positive. Right? Right. So e power minus b, e power minus a. So now they are taking us to take modulation. The modulus. So if you put modulus also, what will happen? F dash of c is this negative will go e power minus b, e power minus a divided by b minus a. Right? So okay, here you see this minus I take outside, I make it positive, so it is e power minus a, e power minus b. Right? So e power minus b, e power minus a. that minus, sorry, e power, that's what I want to emphasize, e power minus a, e power minus b, right? Okay, fine. So if you take modulus, what will happen? This will become like this will become like this, right? So b minus a is always greater than less than 1, right? Because the denominator is greater. See, what is the condition? A is greater than 0, b is greater than 0 means e power minus a, e power minus b is less than always, because this is 1, you see this is 1, so f of b is e power 0 is 1. E power 0 is 1 means f of a is greater than 0 means a is always less than 1, b is also less than 1, right? So f of a and f of b must be less than 1. Clear or not? So this must be less than 1. So the result will be the numerator is less than 1, right? So f dash of c is also less than 1. Yes or no? Because f of c itself less than 1. So this is also less than 1. Clear? So now what we understand, when you simplify this, so this is less than 1. This implies mod EB minus EAS should be less than B minus A. Because if I want this equal to less than 1, the numerator should be less than denominator. So mod B minus mod A should be less than 1. Right? So I simply explain this. It's a simple problem. Right? So what is the thing? If e power 0 is 1 means e power minus a or everything should be less than 1 only. So f of b is simply, we can solve. So this is a tedious procedure I have explained, right? But we can solve it very quickly. How? I hope now you understand the logic. E power 0 is 1. E power minus a is less than 1. A is positive. Similarly, e power minus b is less than 1, b is positive, right? This is what a, this is what b. So this indicates similarly e power minus c must also be less than 1, right? So the numerator should be less than denominator. Yes. So f of b minus f of a, right? B minus a. So these two fellows must be less than 1 means e power minus b or e power whatever it be should be less than b minus a only, right? So simple logic. Next question, if f of x is equal to cos x and c belongs to minus pi by 2 to plus pi by 2, what is the value of c in Rolle's theorem, right? So what they have given, f of x is equal to cos x. As per Rolle's theorem, what is the condition? F of x is continuous? Yes, it is continuous. Is it differentiable? Yes, it is differentiable. Third condition, f of a is equal to f of b cos pi by 2, f of pi by 2, 0, f of minus pi by 2, 0. So I can apply Rolle's theorem, right? What is the condition? F dash of there may be some value c that will give f dash of c is equal to 0. So what is f dash of c? That f of c, f of x is cos x. What is f dash of x? Minus sin x. We know f dash of x is equal to minus sin x. So what is f dash of c? C is minus sin c, right? So minus sin c. This implies sin c equal to 0, right? Sin c 0 means what is c? Sin c 0 means c must be equal to 0, right? So the answer is option B, right? So that's all about the session. I hope you understand everything very clearly. If you have any doubt, please ask me in the comment section. I will clarify. Thank you.